All right. I have adjusted the Lab 2 due date because apparently the import process said it was due this Friday. I made it due on Monday, next Monday, which I think is an appropriate due date for that second assignment. Most of that assignment is of the format of, here's an equation, please get the inputs for the equation and let the computer do the plug and chugging, essentially. You know, here's the equation, surround it within basically a above that equation should be an input statement, getting in what you need, and below it should be an output statement. Once you're finished with that, you'll want to start looking at Lab 3, and I will probably have to adjust the due date for that one as well. Lab 3, and that's also what we're going to kind of go over in this class, which is turtle loops. It's 5 small exercises, and I do think they're rather fun. Please keep, and this applies if you're trying to do work with your turtle. I put it in all caps just to prevent students from making this mistake. It's worked. It's not because I'm trying to be mean here, it's just because when you do that, students suddenly pay attention to that. So don't don't name any of the homework or the files you're writing turtle.py. It's going to make things painful otherwise. But what we'll do with the turtle is we'll learn that you will draw the Olympic rings. You'll draw a clock that looks like this. You'll write your initials. You'll draw some shape. Like I tell you how many sides I want that shape to be, and you'll draw that many something with that many sides, which is also what we're going to kind of be working on today. And then finally, drawing the Triforce, from Legend of Zelda. So, how you do that, for how you do any of these, I don't really care. Like, there's no specific way of, I need to draw 1 triangle, 2 triangle, 3 triangles, or I draw 1, 2, 3, 4 triangles, or I draw 1 big triangle with a small triangle in the middle, right? Whatever way you find easiest to manipulate these turtles and stuff, that's what you do. As long as the output looks good, okay? The extra credit here is the Olympic rings, which, Olympic rings, right? So let's look up the Olympic rings for a second. Under the Olympic symbols, you've probably all seen this, but never actually stared at it, because why would you do that? That's silly. Why would you stare at a logo? And, it's 5 rings of different colors, okay? So getting the colors relatively right is important, but that's okay. Just choose blue, yellow, black, green, red. Doesn't need to be the exact shade or anything like that. That's not what I care about. For the normal credit, you just simply draw 5 circles and they layer on top of each other. For the extra credit, these rings are interlocking. That's the extra credit. The reason it's extra credit is because it's a right pain in the butt to do. So it's worth so it's a ton of extra work, but it's for the extra credit. The ways I've seen students do this is they have 5 separate turtles, each for 1 ring. They draw the rings, so they draw the initial credit, just 5 rings, and they overlap however many. And then they have each colored turtle go over the, like they'll have the blue turtle go over this part again, but not this part. And then they'll have the yellow turtle go over this part again, but not this part, So, and so that's one way I've seen it done. I've seen just some students just do some very cleverly drawn semicircles. So again, how you do it, not really, how you do it, there's a lot of ways to do it. But that's going to be the upcoming homework in Lab 3. It's a lot of fun. And don't worry about it again until you get to lab, but I'm just saying this is where we are ending up. This week's lecture portions are focused on multiple exposures to the for loop before we actually encounter it in the book. The for loop is probably the most essential tool we'll learn for the first few lectures. It allows us to repeat things and do things over and over again without having to copy and paste, because copying and pasting is annoying. We'll first learn it as just simply that, a tool to repeat something. However, as we'll learn later, we can not only just repeat something, but every time we repeat it, we do it slightly differently, which is the other kind of key aspect of this. If you're coming from a language like Java, it's like if you already know some Java, I hope if you have not learned the for each loop in Java or in C#, then the for loop in Python is going to look like a load of nonsense to you. If you have learned the for each loop in Java or in C#, then you'll know exactly what the loop in Python looks like. If you haven't learned loops at all, which is the vast majority of you, it's going to be, you're going to be like, it's going to be a bit of magic at first, just like, oh, memorize the magic phrase. But as we go and use it more, you'll kind of see, oh, so this is how it works. Okay? So today's exercise, and I've updated the, over here, is on this. And again, these videos, by the way, they go over the same exact material as the textbook. The reason I have them is I know some people, it's much easier for them to read the textbook. Some people, it's much easier to watch the videos. Some people, it's much better if you use both. Don't care which one. That's why I have both, because I'm trying to appeal to whatever your learning kind of preference is. So, use what works for you. And again, these are playlists. This is relatively short this week. So today's project is on Runestone, so you can go directly to Runestone, or you can log into Canvas and scroll down and click on this link that says we will do project 4 from the book. If, on the other hand, you logged into Runestone, you log in, you scroll down, go to Foundations of Python Programming, scroll all the way down to the appendices, and then click on Drawing a Circle with a Turtle. Skills required, turtle graphics, repetition, which we're in the process of learning. In fact, the entire point of this is to learn this. So, for those of you who don't remember, the turtle is a graphics tool library for us to draw very simple shapes. We start using it by typing in import turtle, and that activates the turtle library. That basically says to Python, hey, get ready, there's some turtles coming. And then we got to make ourselves a turtle. This is the only magic line that we really have to care about for making turtles, which is our variable name. I'm going to call my turtle's variable name Bob. So that's so I'm going to refer to our turtle as Bob. Why Bob? Because it's 3 letters long and 1 syllable. That's why. Lazy like that. Also because the metasyntactic variable names for security are Alice, Bob, and Mallory. Alice and Bob want to talk to each other, and malicious Mallory wants to intercept their messages. So anyway, Bob is equal to turtle, that's the package name, dot turtle, capitalized, open parentheses, close parentheses. Undercase, uppercase. It's annoying, it's important. Professor Rosen, what if I forget it on a test and I forget to capitalize it? I'm not really going to care that much. That's not one of the things. Forgetting to capitalize it is a minor thing. It's kind of one of those things that if you had a computer, you'd be able to identify that problem immediately. Yes? Why is there lowercase and then uppercase? So this is the package name, and inside the package name is a special kind of function called a constructor. By convention, constructors are capitalized for creating a new object. That's just kind of by the convention to say we're building a new turtle. The new turtle is built, it gets stored in Bob. That is what the variable name means. This is magic that you'll have to wait on for the end of the semester, but that's what it does. Now that we've got ourselves a turtle, remember we can start moving him. Bob.forward, right? Our commands are like something like this, Bob.forward 50. To move forward, to tell Bob to move forward 50, right? We can also, make Bob look nice. I believe it's set shape, turtle. And does that work? Is that it? Is it set shape or is it shape like that? What is it? Or is it just shape? I always have to look it up because, oh no, it's just shape. And there we go. That looks much better, right? We create Bob. We tell him to look like a turtle as opposed to a weird abstract triangle. You don't need to do that. I just like having a turtle-shaped actual turtle. And then you tell him to move forward 50 pixels, and that's what he does. So the idea here is that we are going to build, our end goal today is getting Bob to draw a circle, okay? It's actually a bit of a challenge. So we're going to start out with some simpler regular polygons, right? Polygons are shapes, and regular polygons specifically are shapes with equal sides and equal angles, right? So an equilateral triangle in this case, then we'll move up to a square, and, you know, a hexagon. And when I say like a hexagon and octagon, I mean like the ones that we, you know, that when we ask kids to draw hexagons and octagons, they're the ones they're going to try to draw, not some weird messed up shapes that have like crazy angles in them that are technically octagons. So how do we get him to draw a triangle? And I know this seems like a weird question to be asking, but it's actually worth considering. So because we all know what triangles are. Why are you asking this, Professor Rosen? Because we actually have to like give him directions on how to move correctly. And sorry, I'm just trying to dig out my stylus. It's in here somewhere, I hope. That's a lot of things that would damage the computer screen if I were to write on it. All right. It's somewhere. Yeah, it'll turn up. It always does. So, with regards to that, let's just go and... So in that case, we will just simply do this, and we will just simply do this. So our turtle always starts out facing this way, right? Always starts out facing to the east, moving in the positive x direction. So if we tell him to move forward, like we did, he will move forward. Now, now I said we wanted to draw a triangle. So that means we need to draw a shape. We basically want to draw one of two shapes. We want to we want to do one of two variations of that shape. We want to draw something like this, or we want to draw something along this line, right? Both are completely valid, right? Didn't specify which direction to go. All right. Now, so right now I've got the turtle going this way. So ideally what I want to do is get the turtle to turn. So what I need to do to draw this is I tell him to move forward whatever this amount is. Let's say 50 pixels. Then I have to have him turn left and move forward. And then I have him turn left and move forward again. Right? Make sense? Just simply go forward, turn left, go forward, turn left, go forward, turn left. Just do that again and again, and that works. So the question is, how much should he turn? Now, turning left, right, this command over here, bob.forward, moves forward a certain number of pixels. Bob.left turns left. And it takes in a number, which is the degrees. So the big question here is, how much should I turn? What should that number be in there? Yes? 120. Yes. Now, some of you are thinking, wait, 120, I was thinking 60. Because after all, you've learned very early on in high school that the internal angles of this are 60, right? So you thought maybe I should turn left 60. Which is completely fine, because you do want to create a 60-degree angle there. But currently we are facing this way. So let me extend this line out a bit. This is a 60-degree angle, and over here we are 120. And because we're facing this, now if we were facing this way, yeah, we'd want to turn like 60 degrees to the right. But since we're facing this way, we need to do the other. And then once we get here, it's the same deal. Once we get here, it's the same deal. We want to turn another 120 degrees. In fact, we've learned that you learned that basically that the internal angles over here add up to 180, right? Question. In a square, what do those angles add up to? 360, all right? And now, in a, let's say, hexagon, oh, I'm terrible at this. Okay, yeah, like I said, I'm terrible at this. But in a hexagon, what do those internal angles add up to? Assuming it's a regular hexagon and I could actually draw. Right? These are, I'll give you a hint. It's a 60-degree angle. The 360. In fact, for all polygons except for the triangle, you're looking at 360 degrees. So we'll keep that in mind over here. But, so actually, as it turns out, what we want to do over here is we want to turn 120 degrees here, 120 degrees over here, and 120 degrees over here, which actually does add up to 360, oddly enough. So, put in 120 and get them to turn this way. So I'm going to give you a second. So now, first off, I want you to complete this code. Make him draw a triangle. And then the second part is we want the user to ask for a side length, which is to say, how big should this be? As opposed to 50, it should be something else. So first, work on getting him to draw that triangle, right? Sound good? So take about 2 minutes to do that. I'm going to go and ferry through my bag to see if I can find that stylus. No, it must be at home. Okay. All right. Everybody kind of got at least the triangle drawn? Right. So hopefully you were lazy and did something like this, which is the correct thing to do, which is that you go, oh, I need three of these. So I selected these two lines. I hit Control C or Command C, and then I pasted with Command C or Command V or Control V, right? And then you run it, and you got something like that, right? Hopefully you did that, or if you're using the mouse, use paste, but honestly use those keyboard shortcuts. They're much quicker. Okay? Now, we want it to move, so a couple things first. We want it to move an arbitrary amount of space. Basically, we want the user to tell us how big it's going to be. So the way we do that is we say we want it to move. Well, let's go ahead. We get the side length from the user. We say int, and then input I'll actually split it up here just to make it a bit easier to read. Input is equal to enter side length. And then I will say side is equal to int side. So I'm going to get it from the user and I'm going to convert it into an integer, because if I don't convert it to an integer, then it's going to be a bit weird. And rather than moving 50, I'm going to tell the Bob to move forward that length. Why? Because that's how big I want each side to be. Make sense? We want it to be that big. So now if I say, hey, can you do 100? He does. He makes a bigger one. So let's go ahead and just get that on the screen for a second. Just enough time for you to copy it down before I delete it, because I will be deleting this. This part is the part I want to rework here. Right? We ask the user for the input, we get that input, and then he moves forward that amount. So he moves forward that amount, and then he moves up, then he turns left 120 degrees, moves forward that amount in that line, 120 degrees, moves forward that amount, and then he turns left 120 degrees. He doesn't need to necessarily turn left 120 degrees on that last one, but out of practice we will be doing that, because when we're drawing these kind of shapes and doing this kind of stuff with turtles, if we're drawing shapes like this, I always find it a good idea for the turtle to end up where it started and to be facing the same direction when we start, because I'm stupid and I don't like to remember things too hard. So if I just remember, if the start point and the end point are the same thing, I don't have to require that much, I don't have to require that much brain thingy. Thinking, that's it, yes. All right, again, it's very hard to, right, we want to keep things simple for ourselves. Don't make things harder for ourselves. Speaking of making things harder for myself, one thing that I did make harder for myself doing this is that I had this side variable over here, right? I took it in, and then I had 50 over here, and I had to replace each of those 50s with sides. And if this was like a this is a triangle, so I had to add 3 of those things to replace. If it was a square, I'd have to replace 4 of those things, right? And if it was an octagon, I'd have to replace 8 of those things. And if it was a megagon, I'd have 1,000,000 of those things. A megagon being a 1,000,000-sided polygon. The things you learn when you have a child who when you have a kid that's less than 8, they'll be asking you questions like, "Oh, an octagon? That's an 8-sided? What's a 1,000,000-sided?" And so you have to look it up. So yeah, you can imagine copying and pasting 1,000,000 times would be rather tiresome, and then having to go back and changing one number a bunch of times. I mean, find and replace just won't cut it at that point. So instead, since we know how many times, since this is going to happen all the time, since this is going to happen like a bunch of times, and it's just going to be repeated, let's write it once and tell the program to repeat it a bunch of times. And so this brings us to the for loop. So over here, let's reorganize this. Here, I'm going to go ahead and get the turtle set up. So that stuff is just all the turtle setup is up there. Here's our user input so we can get our variable to get started. Okay, and now we'll get the turtle moving. For is basically going to look something like this. It's going to be for x in y. Don't copy down the for x and y. It always just follows this formula. All the for loops you will do in Python always have for something in something. What those are going to be are going to change. Today, what we're going to learn, x is very simple. We're going to put in the underscore here for I don't care what x is. It's blank. Read it as for blank. I don't care what it is. So now we only have to worry about one thing. Make sense? For blank in, and this is the magic word we're going to use, range. 3. So range is going to be 3 here. And notice so basically it says for blank in range 3. You can put whatever you want here. You could put an X, you could put an I, if you're coming from a different programming language. But the underscore just means that we're not going to use that variable. That's what it means. We're always going to have to use the Y part over here, this range. Okay? And notice the semicolon. Now, it's not the semicolon, the full colon. As soon as I hit enter, when I put a colon, it immediately automatically indented over here, right? Notice that my cursor's not at the end of on the left side of the line. It is slightly indented over here, right? Everybody see the indentation? Okay. So the colon says to Python, get ready, there's an indent coming. And why does that indent matter? Because, and this is going to sound like utter blasphemy for those of you coming from another programming language, we know what's inside the for loop by figuring out what's been indented inside of it. So here, we will do bob dot forward side bob dot left 120. Move it. So I put in 100, and there it goes. Let me zoom out for a second, just because. So, right, I put it in, and now we can see it in action that it moves. And it repeats the lines I wrote 3 times. 1, 2, 3. So for blank in range, and it does both these lines there. I'm going to go ahead and do a print statement here, so that we'll get some text right over here in the gray box. Print done. And this is just I'm doing this to kind of show you what I mean about indentation and being inside. So I'm going to save and run this. So for blank in range 3, move forward that side length, bob.left 120. I'll share this code with you, okay? So 100. Doom, doom. And it printed out done. Yes?
What is the blank, like, just to represent the underscore?
Normally you'd have a variable there. And it would change, and the variable would be 0 the first time, 1 the second time, 2 the second. We don't need any of that right now. We're learning how to use this for repetition.
Okay.
So we don't need the underscore. When we put an underscore there, we're saying we don't need this thing.
Okay.
Does that make sense?
Yeah, and for repetition, you just use range?
Yeah, for a repetition, we use range. So we do done there. We'll be going over what range actually does in more detail on Thursday. For right now, we're just keeping the for loop over here. This says, do this, whatever is indented inside the for loop 3 times. Notice that we did the for, it printed out, so it runs, 100. So it runs, and then it prints out done, right? The done didn't print out until it was done drawing. So now let me go ahead and hit tab and indent the done into that for loop. Okay? Now notice that the print statement is inside the for loop. If I put in that, it prints out done every single time it did a side, because it was inside the for loop. Inside the for loop, outside the for loop. In case you're curious how many spaces that is, by default it's 4 spaces. But generally you use tab and it will automatically put in 4 spaces for you. Okay? So that is the role of that indentation. This is inside the for loop. Now, you've probably figured out that the 3 means this repeats 3 times. So if I put in, 12, it's going to repeat 12 times. Let's go ahead and quickly scroll down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And you can put in as many as whatever number you want there, and it will do that many. Although, if it runs for like more than 30 seconds on our on the web page, it will automatically interrupt the program and crash it, because it doesn't want to freeze up the web page. It doesn't want to freeze up your web browser and make you lose a bunch of work. So I'm going to hit share code so you can see this. Okay, so you can just simply reload the page. Now, hit F5, reload the page, and there will be and you'll be able to see this code. Or you hit this button and refresh the page, and you'll be able to see this code shared in your timeline at 2:30. Okay, you want to, so, because I know sometimes you're like, oh, I can't get this working, I was trying to copy it, I thought I did everything right, and you probably just like forgot maybe the colon over here, or you capitalized wrong over here. You know, that happens all the time, so I want you to have a working copy of this code. So, and what this does again is that, so the for blank in range will repeat whatever in here, whatever inside of it, this many times. So in this case, it will do this line 12 times. So now with that, take what you know, literally take this code over here. I would literally go copy and paste, or, you know, whatever, and then, or, you know, type it out yourself if you want that extra practice. Ask the user for a side length, and then draw a square, right? Squares are four-sided shape. Triangle was a three-sided shape, okay? So we went from 3, so we're going from, so this was 3, so you're going to want to change that. And then to 4, but if we change it to 4 just straight away, right? It's not going to work. It's still going to give us a triangle, so you'll want to, so you've got to change something else. A couple minutes on that one. It's a very quick change. So just a few minutes, or actually more like a minute. Yes?
So we always have to put import turtle at the top.
If you want to use a turtle, yes, you have to put import turtle at the top. Yes. Sorry, what you want to repeat? No, just need to draw the square. I was just, the whole thing with the 12 was just kind of to show off the, okay, you can change it from, 3 isn't the part, 3 is the part you want to change, right? So keep it in this format, the 4 blank in range. The only number that you should change in the outside, you know, in this 4 statement is that number, which we've said, oh, if we need to repeat something 4 times, yes.
Can I show you something? It's not in my forward in range statement. For some reason, I don't know why.
Okay, I'll quickly take a look. Yeah. So it's a bit hard to see up there, but the 4, the underscore, sorry, the 4 and the in are purple, and this is black. It's a bit hard to see on the screen, you know, on the projector. So if you don't have spacing correct or something like that, it might not show up. I mean, it doesn't matter how many spaces you have. You just want to make sure there is space. So for this one, right, what we needed to do was just simply change that from a 120-degree turn to a 90-degree turn, right? And that's what we wanted to change. The turtle needs to just change the turn they need to make. All right, so the next one should be fairly straightforward. Ask the user for a side length and then draw an octagon. Okay? So we're going to draw an octagon now. So, right, it's an 8-sided shape. So take this code, modify it to go with an octagon. Now, there are a couple ways to have gotten to the right answer here. And it just depends on how your brain decided to be working today. So first off, you're like, okay, 3-sided shape, 3. I'm gonna fix that to 3. We just simply change that to 12 just for experimentation purposes. 4-sided shape, 4. 8-sided shape, we're gonna do 8. So take this, copy it, change it to 8. Right? Change that to an 8-sided shape. Next thing we need to do is that we need to change the angle, right? So also the other way to think about it is I need to draw 8 sides, which means I need to physically draw 8 straight lines. So 4.side, that's not going to change because we know how big each side is. And the amount, well, you think, okay, I need 4. I'm doubling the amount of turns I need to make, which means that I need each turn to be half the amount.
45.
So go to 45. Now another way, so that's one way we could have arrived at the answer, which is to do this. And, kind of goes off screen if you do 100. If you do 75 or 60 or whatever, it's definitely going to stay on screen, right? Because each side is getting bigger, each side is getting to be a relatively smaller portion of the overall shape. So the overall shape gets up being bigger. So here he's doing 45. The other thing to note is that, again, the amount of total turn the turtle needs to make, be it a triangle, the amount of total turn that we need to make is 100 is be it under a triangle, a square, or an octagon is 360 degrees. Look at this. 120 made 3 120-degree turns. That's 360. 4 90-degree turns. 4 90-degree turns, that's 360. 8 45-degree turns. That's also 360. 8 times 45 is the same as 4 times 2 is same as 4 times 2 times 45, which is the same as 4 times 90. So when we draw a polygon or any kind of shape, we're going to be if we want to end up, at the same kind of location, in the same position we started, and at the same angle we started, we need a total of 360 degrees, right? Everybody knows that. In order to end up if you're spinning, right, and you want to do full spin, that's 360 degrees. So that's why it's got to add up to 360. Okay? So now we're slowly getting to our end goal. And our end goal is we want to draw a circle. However, we've got a few issues. First issue is it's physically impossible, actually. That's our first issue. We actually can't do what we're setting out to do. It's physically impossible, just mainly because of the how we do our computers, which is that our computers are made of tiny little squares. Pixels are tiny little squares. There's no way to actually make a circle there because no matter what, all we can do is draw straight lines, and we can kind of cheat by aliasing some squares, doing some anti-aliasing actually, where basically we make some of the black squares those areas between black and white gray to make it look like it's a bit rounder. But overall, we can't do that. We can't actually draw the shape we need. On the flip side, though, does it really matter? Let's go back to the megagon. Megagon. Now, this is a 1 million-sided shape. But if you were to go to, somebody and ask them, hey, what shape is this? They're not going to say, oh, it's obviously a megagon. They're going to tell you it's a circle because it looks like a circle, right? This is a circle. It looks like a circle to me, even though it's got a million sides. It's a shape with a million sides to it. And actually, okay. And if you think about it for a second, the more sides we add to each regular polygon, from triangle to square to octagon, we're getting a progressively better, each one gets progressively better as a wheel. so to speak. They each get closer to a circle. I'd rather, if I had to choose between a triangle as a wheel, a square as a wheel, and an octagon as a wheel, I would go with the octagon, And as we go forward, so the more sides we add, the better the shape is going to be. Okay, so that's our first thing. So we want to add more sides. Just basically go and get enough sides. So make a so that's the first thing. So that is number one over there. Number two, they have a third thing they need to figure out. Okay. Number two, how can we figure out how far to make the turtle turn for the triangle and square and octagon? Well, it has to add up to 360 degrees, as I mentioned. We kind of just discovered that rule. And because we know, and each turn is going to be equal, it's regular. That's what it means. It's going to be equal. Each side is going to be exactly the same. So this actually allows us to cheat for other shapes. So if I, for instance, go to a 16-degree, 16-sided shape, or 15-sided shape, let's go with that one. What am I supposed to turn? I don't know. I'm lazy. Be lazy. But be lazy in a smart way. That looks about right. If it's a 15-sided shape, and I know it needs to be 1500 degrees, and I know it needs to be 360 degrees, I take each side and go the amount, each turn needs to be 1/15 of the total amount. Yes?
Is there something you could put instead of having to rewrite whatever's after range so it just goes automatically?
Yeah, I could write a variable like this and do something like this. You actually predicted what I was going to suggest next. Num sides is equal to however many we have over here. And now I can just do num sides and num sides. And now if I want a 15-degree shape, let's go ahead and do 15-sided shape, which, as you can see, is already looking more and more like a circle. And if I want now a 10-sided shape, okay, and I scroll down, I only had to make one change now in my code, which was the number of sides, right? What is num sides? It's 10, right? We do this 10. We want 10 sides, so we do 10. So we're going to do this 10 times. We're going to draw a side, and we're going to turn 1/10 of 360 degrees, right? 1/10 of the total amount. Okay, so what we did is we abstracted this. We went from 3 and 120 to 3 divided by 3. Sorry, 360 divided by 3. We went from 4 and 90 to 360 divided by 4. And so now we can make this a bit more abstract. Hit the share code button so that you can get this. This is going to be in the octagon shape. So that's number 2. How do we figure out how far for the turtle to turn? If we want it to turn, it's going to be there. So now our question. Ask the user for the radius and draw a circle with that radius. So there's the kicker. Okay? Because what are we asking for in these problems? Side length. What are we asking for here? Radius. And in case you're like me and sometimes a bit slow on the uptake on that, because I certainly am. I didn't realize that the first time I was programming. Right? This is the side. Right? A radius, okay, circles are defined by radiuses. Okay? Where you have some central point and then the circle is like that, right? Actually, here we go. No, I want. So there's a circle, and then there's a center point in the circle. Okay? So, let's see. And everything is some radius from this point. Okay? So how do we get from here? How? Okay, right? Obviously, I would know I know the answer because I'm teaching this class. I would hope I would know the answer and not be, leaving this as an exercise for the students. But what it is that, again, first off, remember, we're cheating. We aren't actually drawing a circle. We're drawing something that looks like a circle, okay? And we also have another thing. So while the side length and the radius are not comparable, we do have something that is kind of comparable. For a square and for any other polygon, we have the perimeter, right? And for a circle, we have the area, we have the amount going around the circle, which is called the circumference, right? One of my favorite puns of all time is from the Discworld novel. It's about a fantasy world that is on the back of a giant turtle, on the back of 4 giant elephants that are on the back of a giant turtle going through space. Great fantasy novel. It's immense satire, but it's this flat world. And so, of course, there needs to be something to keep things from falling off. So there's a giant fence called the circumfence, because that was the kind of author Terry Pratchett was. You should read his books. It's great. Anyway, so we have the perimeter here, and we've got the circumference. Okay, the perimeter is going to be equal to, right, the perimeter is equal to what? It's equal to the side length, right, times, how many sides there are, num sides. That's how we figure out what the perimeter is, right? Okay. The circumference is we've learned a formula for that, right? Which is 2 pi r, right? Which is that's basic, and that's what the circumference is, 2 pi r. Okay, so if we want to draw something with a radius, with some defined radius, what we need to do, whoops, didn't mean to do that. I meant for, don't go there, stay there. Okay, what we need to do if we want to draw a circle that has a radius of some kind, we're instead going to draw a shape that has a total perimeter of 2 pi r, where r is the desired perimeter, okay? Desired radius. So they're going to tell us what the radius is. Instead of going and drawing something with a radius, we're going to draw something with a perimeter instead, okay? Now, you might be asking, how do we get from here to here? Well, first off, let's say go ahead and go back and say, let's go ahead and start off and just put some numbers in, okay? Say we want to draw something with a perimeter of 50, okay? With a radius of 50, a circle with a radius 50. That means the total amount our perimeter needs to be our perimeter, yes, our perimeter and our circumference need to be is 100 pi, right? So we need this, the num sides times the side, to be equal to 2 pi r. Oh no, you realized I've tricked you. You're doing math. Okay, 100 pi. So now what we've got is we've got this for loop tool, right? Which says, hey, for this turtle, right? We've got this number of sides. Okay, we know how much he needs to turn. It's whatever amount we decide our lie of a circle is going to be, like 30, 32. That's going to look a lot like a circle. So how much does he need to move forward? That's how much. Rather than doing side, we need to know how much he's going to move forward. So we know that this is, in this case, 100 pi. We'd want to draw, if our shape was like 30-sided, we'd want him to draw 1/30th of that amount. Let's go and abstract it out again. 2 pi r. So how long should each side be? Well, we just do some basic math. Take this, divide over here. Num sides. So each time we want to, so each time we go, we want to turn 360 degrees, divide by the number of sides, and we want to move forward 2 pi r divided by the number of sides we have. Does that make sense to everybody, or did I lose a bunch of people along the way? Yes? No? Yes, I lost people? No, I didn't lose people?
Lost.
Okay, lost. Got it. Okay, the idea here is that when we're drawing a circle, so let's go through this, because we've got plenty of time. This circle's a lie. Can't draw a circle because there's just too much. Can't make that even. So instead, what I'm going to do is I'm going to cheat. I'm going to draw something like a 30-sided shape. A 30-sided shape, 50-sided shape, whatever. I'm going to choose some number. It's going to look a lot like a circle. So, so for instance, if I change this over here to 40, right, and I now have taken the input for the side, right, and I say each side is going to be 50, you can tell it looks a lot like a circle, but also typing in the side length for 50 gave me a humongous circle, one that's bigger than I could use. And that's because circles don't have side lengths, so putting in a side, telling me how much the side length is isn't very useful. Instead, the useful thing to plop in is a radius, which is the distance from the center. A radius of 50, radius of 100, that'd be really good for us to draw. But then that tells, but I'm not actually drawing a circle, so even though I'm going to be receiving a radius like this, let's go ahead and copy and paste it over here, right? Instead of taking in a side length, I need a radius. Radius of fake circle. Okay? And then we're just going to convert that radius into whatever. Okay? So we have our number of sides, we have our radius. So rather than moving forward some amount up for our side, that's what we're going to figure out, the amount of turning we need to do is going to be exactly the same because we're still making a fake 40-sided, 50-sided shape that we're pretending is a circle. Okay? Now that's not too hard to figure out. We figured out how much we need to turn each time. If this is a 40-side shape, we need to turn 1/40th of the total amount, right? Each turn is going to be exactly equal. If there's 40 turns, then we turn 1/40th of the total amount, right? And because it's going to look like a circle, it's going to be 360 degrees total, right? So that's not going to change. It's the same as it was. Similarly over here, because each side is going to move forward, right? Each side is going to move forward a certain amount. We need to figure out what that is. Well, it's going to move forward a certain total amount. A certain total amount, and there's, say, 40 sides, right? So each side, because we know each side is going to be equal, we're going to do 1/40th, or however many it's going to be, of that total amount, right? This is the total amount I need to move. This is and that's 1/40th, 1/50th, whatever we plug in for one of those. So the main issue is figuring out what the heck is this thing supposed to be? Well, in a circle, right, the total amount that you need to move is, if you're going to trace around the circle, the total amount you move is 2 pi r, right? 2 times pi times the radius, right? This is the total amount you go around in a circle. That is 2 pi r. In a square, or octagon, or pentagon, or hexagon, the total amount you move is the perimeter. Okay? or we just often just call it P. Okay? So the perimeter needs to be equal to 2 pi r. So where pi, where we 2 pi, those are just a constant number, r is the number that's provided to us. So we just need to make this equal to that. So now the perimeter, the way you figure out a perimeter is you take the number of sides, so num sides times the length of each side, right? So we need to make those two things equal. Perimeter is equal to the number of sides times the length of each side. So what I'm doing is now this is an equation here. We've got number of sides times length is equal to 2 pi r. And since it's equation, I can do all those annoying algebra stuff that Algorithmity figured out, which is I can take this multiplication and divide both sides by it. In other words, move it over to the number of over here. We get 2 pi r is the num sides. So the total amount I want the turtle to move each time in the for loop is that amount. So 2 pi r times the number of sides. We have number of sides. We have the radius, right? We have number of sides. We have the radius. And we have 2, and then I don't have a pi on my keyboard, so I'm just going to approximate it, right? 3.14159 something, 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 something. Doesn't really matter how many you put in. Once you get to this point, you're probably fine. Okay. So now, code coach. Oh, right. Right. I can't just plug this in. I have to also just one of those times. I think my cursor messed up when I was typing that out. So 2 times pi times the radius. Honestly, it looks a lot easier sometimes if we just simply say pi is equal to this, rather than just trying to remember it. 2 times pi times the radius. There we go. And now, enter the radius of fake circle. I want a 100 radius. Okay. So again, the reason this worked was because we knew that this is going to be the amount that this, right, runs 40 times. 2 times pi times the radius. I mean, if we just simply make the radius 1 for a second, just to be, I know that's rather silly, because we're going to draw like something that doesn't really show up on screen, but like this, so our total amount that he turned was 2 pi, right? And since we had 40 sides, each turn he did was 1/40 of that, 1/40 of 2 pi. Make sense? So we had some total amount, right? So we can actually pull this out and say this is the perimeter. It's equal to 2 times pi times the radius. Actually, let's go ahead and, right, we can't use that before radius is declared. And we can say perimeter is divided by the number of sides. 60 divided by the number of sides. Make sense? So what I did is that this is exactly the same as what we were doing over here, right? We moved forward a certain amount. We just didn't figure out what the total amount was and put it in terms of the total perimeter. And that's what I just did over here. I put it, here's the total amount that I need the turtle to move, and I tell it to move 1/40th, 50th, 60th, whatever I put in. So if I put in like 25 over here, now it's going to adjust. I can still use it. Still looks like a circle. It's only when I start getting down to like 15 side shapes. Oh, sorry, I didn't change that to 15. I mean, obviously, the smaller I make it, the more it's going to look like a circle. So 100. So here's a 15-sided shape. It looks like a circle, but it's not, but you can kind of tell. Not really. But of course, if you like bump that up to like a 60-sided shape, and you made it 200, like that looks a lot like a circle, right? So let me go ahead and share that code with you. Usually I would try to get you there, but I felt it was worth it to kind of lead you through that because the math can sometimes be a bit weird. Yes?
Yeah, so is there like any particular reason why we should use integer division here rather than just like regular division, or like could we also use this like single?
It's force of habit for me. Okay, I don't like thinking about half a degree. I don't like thinking about half a degree. Over here, this probably honestly could be that. I also don't like thinking about half a pixel. So, yeah, there's no reason why you couldn't do that. There's literally none whatsoever. The Python is nice and will adjust that. Fortunately for you, so the good news is that if we look at the Turtle docs, okay, Turtle docs driving, so Turtle, Python Turtle doc, okay. We can get really intricate shapes by doing this, right? But if you need to draw a circle, you don't need to, follow what I did. It has a built-in circle, right? And you do exactly what we did here. We provide it with a radius. And then it fakes drawing a circle, right? So let's see that in action with the last one. I won't go through the bonus part. I'm just gonna, you can try it on your own to manually do what which is ask the user for a radius, then draw a circle with that radius, but the center of the circle should be the current location. That involves just having to move the turtle, make the turtle lift his pen and adjust a bit before and after drawing the circle. So you don't have to try that, but I want to show you the circle in action. So import turtle Bob is equal to turtle.turtle because you're going to probably want to use this when you're doing the Olympic rings, right? So let's go and say Bob dot circle, and first off we'll start off with 100. And it draws a circle, right? Or again, it doesn't draw a circle. It looks something like, you can see there's like its edges and it's jagged. It looks something that looks a lot like a circle. Okay, but that's also a function of the fact of what we're dealing with in terms of code. So there's also some other things here. It says radius, extent, steps. This means there's optional things we can feed in. So let's just experiment. What do I mean by that? Well, I gave it one thing, a radius. 100. Let's go ahead and try 100. What in the world? Yep, there we go, extent. So I know exactly what extent is now. Even if you don't, 180. That should probably clarify things quite considerably. So you can draw an arc. So why 180? Remember what I said? It's 360 degrees. This did only 180 degrees of a circle. 45 degrees of a circle. There you go. 360 degrees, I'm sure. Wonder, and of course, I actually never tried this, so I want to try it. What happens if I do 720? I am very curious. Does it, yep, it goes around twice. Okay, again, least surprising behavior there. And then steps, as the circle is approximated by an inscribed regular polygon, fancy words for what we just did, okay? Steps also determines the number of steps to use. If not given, it's going to be calculated automatically. What does that mean? Well, inscribing a regular polygon, if we give it 15, I think you'll see what I meant. So draw a circle of radius 100, the full circle, please, and I want steps to be 15. The same thing we've just been doing. We just kind of did from scratch. If I do a 6, there you go. So it calculates that, so it's drawing a polygon. If you don't provide that number, it just figures it out automatically what's going to look best based on the size, which is pretty cool. That's very nice to not have to think about that. But I mean, here's a 100 cytagon. goes through it pretty quickly and it looks nice and clean and stuff like that. So yeah, it's exciting to see that that was as easy as that was. Now, one last thing before we head out. Let's go back up here to, because the important thing was the for loop, right, over here. And we had a certain number of sides. So I'm just going to comment this out for a second. We entered how big we wanted the size to be. And this for loop said, hey, however many times we want to do it, let's say 50, right? We're going to repeat this action 50 times. Now, what we were doing here said every time we want it to be an even turn, right? We wanted to turn an even amount, or rather an even division of 360. So what if I did something along the lines of this? It's always fun to experiment and see things. So I did 65 degrees rather than 60. And you'll notice that it started drawing a hexagon, but because it's 65, I'm asking it to turn a little bit more. It didn't exactly line up, right? It didn't. So let's go ahead and do less turns so we can see this in action. 8 turns. We'd normally do 60 for a 60. We'd normally do 6 60s for a hexagon, right? Here, we are doing 8 just so we can see what goes on beyond it. Let's start out with 6. That's the amount we turn. 6 times 65, that is 360 plus 6 times 5, which is 30. So we're going an extra 30 degrees. So, and by going an extra 30 degrees, we don't quite match up at the end, right? And it's no longer regular because the turns are a bit too big. It doesn't fit. But as we go on, 10, right? And this is actually you can do some really wild stuff with some weird angles, right? Right, so here we can get a star pattern going. Now, let's do 200 for a second. So, unfortunately, this pattern is going to take a bit too long to draw, which is annoying, right? Bob.speed. Fortunately, our turtle can be a bit more zoomy than our typical actual tortoise, which might be helpful if you've when we're doing our homework. So, it takes in a number from 0 to 10. 1 is very slow. Sorry, 1 is very slow. As you can see, it is rather tortoise-like there. Over here, what I'm going to do is instead, and if you do a 10, okay, it's going to time out. So this is a great example of timing out here. Oh, God, it's painful to watch, right? Agonizing, in fact. Yep, there we go. Error. Program exceeded runtime limit. This you might come across a few times. This is a safety feature in case you write what's called an infinite loop, where you get a for loop and you program, and you don't have to do range here. There's other things you can do. Range is just the way we're looking at doing things right now. But you can program your loops incorrectly, and you might end up doing them forever. This is a safety measure against that, so that you don't lock up your web browser. So now speed.10, we'll see goes considerably faster, right? Considerably faster. Okay? And now, finally, let's go ahead and 0 is actually the fastest, ironically. 0 is actually the fastest. 0 just means as fast as your computer can render it, please. Which is pretty cool. You can also do some other things with that, which is, and here is where this comes in, and this is going to lead into what tomorrow. This produces a number. Range basically says we're not just that we're going to do this 100 times, but actually this is going to produce, if I pull up idle for a second, please bear with me to the end. Trust me, I'm going to make it worth it. Okay? Okay, if we do this, we get, so if range 100, I have to do some weird commands here for a second, but if I, which is, I take the range, I convert it into a list, okay, and then you'll see that the range is a range of numbers. Specifically, it's from 0, it's all the numbers starting at 0 up to, but not including 99. We'll learn why on Thursday, why it's 0 through 99, not 1 through 100. But 0 through 99, there's 100 numbers. That's why it goes 100 times. So what I can do is in the loop, I can have, so I remember about this x, I said it could be something, this was a variable. Sorry, this underscore was, it could be a variable. So if I say x, if I print out x, right, over here. So 200. It starts going through and printing out all the numbers through it, right? So that variable change is, that's going to make it hard to look at, so let's not do that, not print it out. But what we can do is I can start doing this. Bob.color is equal to, let's go with 1.0 minus 0.01 times x, red, RGB, green, so that would be 0, let's go with 0, no green, and then what we'll do is we'll increase the blue, 0.01 x. You don't need to understand any of this, just understand that I am changing the color here. And I'm changing it over time. And this is kind of what for loops can be used to do. We're going to do 200. And if you notice, it changed color as we went on. Specifically what I did is that we started out with 1 amount of red. So the way color works for turtles is that 1 is fully on for the red and 0 is fully off. So we had no green. So we started with fully on red and no blue. And as x got bigger, right, at the beginning x is 0, then 1, then 2, then 3, then 4. This is something we're going to go into plenty more detail on Thursday. Consider this a preview, not something you have to know. All you have to know is that that if you see a range 100, it means 100 times. So this slowly got stronger and stronger, and the reds started getting weaker and weaker, so that we could have this, oh, I said 2,000 rather than 200. Well, still very interesting, but you can see as it's going by, when it decides to come by again, it will we've got this gradation of color. All right, so I will share that just with you, just in case you want it as a reference again. Make sure to share this with you and share this with you so you can see that. But try and working on this one on your own. Remember to fill out these questionnaires at the bottom. And that's it. So let me go ahead and stop recording.